All right, 11C, number 2. Several regression lines are used to predict the monthly sales in a certain company from different independent variables. Residual plots from each regression are shown below. Match the description with the plot. You may use the same description more than once. So A has an RMS error of 1,000. What does having an RMS error of 1,000 mean? So it's the average distance from the point, from the regression line would be 1,000. Visually, what does it mean? How are we going to decide which one has an RMS error of about 1,000? Well, if we go up 1,000 and down 1,000 and draw those lines, I should capture about 2/3 of the people. So would A have an RMS error of 1,000, 5,000, or something's wrong? Why is something wrong? Is that what the back of the book said? Somebody check the back. Mike? It's not football shaped, so we have a bit of a problem there. Okay, what about this one? That would be 68% of the people. And then what about 3? B is 5,000? No, it should be 1,000. 5,000 is going to put us way over the top. What's that? C, number 2. Let me look at that. C2, not used. Oh, that's looking at the letters. So A and B both are 1. So 1 is not football shaped. That's what I was wondering. But it still has an RMS error of about 1,000. It's not going to be perfect because it's a little bit egg shaped. And then 3, something's definitely wrong with 3. So what the back of the book is saying is A goes to 1 and 2, and then C goes with 3, and 5,000 is never used. Well, she just read she read it wrong. Okay, does everybody understand that? Okay, and number 3. Let's get a new. Look at the figure below. Letter A, is the SD of Y about 0.6, 1, or 2? So we have our point of averages, which is, it doesn't tell us, but it's about right here, about 4. How high do I have to go above and below 4 to capture 68% of the people? Would it be 1? If I go up 1 and down 1, that looks about 60% of the people. What if I did 0.6? So here and here. Does that look like I captured 2/3? No, looks like I captured 1/3. And then 2, if I started at 4 and went up 2 and down 2, do I capture 2/3 of the people? Nope, I captured almost all of them. So that's the SD of Y. Now B, is the SD of the residuals 0.6, 1, or 2? So now I come over here. Let's do 2 and 2. How much did I capture? Everybody. So that wasn't it. Did I capture 2/3 of the people? No, it looks like I captured about everybody. Okay, and then 0.6 and negative 0.6. Okay, what do we call the SD of the residuals? The RMS error. So this problem is a really good way to see why the RMS error is smaller than the SDY. The SDY has to cover this much ground in order to get 2/3 because the regression line is increasing. But if we make the regression line 0, then our SDY of 1 gets converted to an RMS error of 0.6. Right? C. Take the points in the scatter diagram whose x coordinates are between 4.5 and 5.5. Is the SD of their y coordinates about 0.6, 1, or 2? So we're only going to focus on this column. So here's the average. Okay. If I go up 1 and 2 from the average, do I capture 68% of the people in the red column? Nope. I captured almost everybody. And 2 is going to give me the same thing. So if I go up 0.6 and down 0.6, do I capture 2/3 of the people in that column? Yes. Oh, that's interesting. The SD of the column is equal to the RMS error, or the SD, of the residual plot. Does that make sense? Well, yeah, it's always going to be that way, because if I draw a new column, then my SD, this size of an SD right here, can be moved into that column, and it will be exactly the same shape, because it's football shaped. And I can do that with every column, which is why over here, the SD of every column is exactly the same, which is the SD of the RMS error. Okay?